Hey guys, so on the last video I did about building a flow bench, I've had a few additional questions, so I'm going to clarify just a couple of things. So I'm going to get over here to the bench. So whenever you have your manometer, whether it's a U-tube or a well type like mine, okay, you have to do a sense line as close as you can to the dead part of the port, okay? So Bernoulli's equation, basically if we create a venturi here where this tube is at, by rushing air past it as fast as we can, it's going to give you a false reading. So it needs to be put in an area of the port that is slow airspeed as possible, or little to no airspeed movement past where the sense line is coming from to get an accurate reading. Okay, so in mine, turn the light on here. Okay, if you look, it is basically completely unobstructed. See if I can get it to focus here. There. If you notice, it completely is barely recessed in. Okay, so that hole is drilled, sanded flat, and it's barely recessed in there. Okay, if I go closer, you cannot see it. Okay, it goes flush. All right, so also the bore plate, or the bore, it's a 4-inch bore, okay, going down, and that's where it expands out to a 6-inch pipe. Okay, remember that's to slow the airspeed down going around that transition so that we can get an accurate reading across our orifice plate. Okay, so when I say get it as close as you can, depending on how you build, I drilled mine in literally right below the bore plate adapter, whatever you want to call it. Okay, also I didn't show this in the last video, that what I did was I took tough as nails, okay, and it's like a, you can use tough as nails, or you can use, I used this one actually, I didn't use the tough as nails, I used the clear epoxy, and I know you can see some air in there, but there's no air around the perimeter, okay, and this is just, it's flexible versus the wood, this is impervious, which means air won't flow through it. Wood is pervious. Even though you're not going to have enough flow for it to really matter, it will eventually over time wear and create little pockets that bend and allow air to pull in from around the adapter. So you get something like this that's rigid, impervious, sealed all the way around, and then once that's sealed, when you clamp the head to it, it will have enough flex in this plastic to form to the actual cylinder head. Okay, and the way I use, okay, I clamp it down with these quick grips on the front and the back, and then once the head is on there, I will turn the bench on. Okay, this right here, you can use Vaseline. I use Aquaphor because I have kids, and so there's always tons of that around. It's basically Vaseline. Put just enough around the perimeter of the bore, okay, clamp the head down, center it, lay it down, okay, and I think that's kind of self-explanatory. Just make sure you square it up, put the end of the bore here and roll it down, make sure it's perfect, tighten it on the back, tighten it on the front, and then turn the bench on. With no valves open, you should be able to pull this bench up to 28 inches of water and have zero flow across your orifice, 0 DP across your orifice. If you have DP across your orifice, make some adjustments, try again. Also, around the bore, you have all these water jackets, okay? And if any of these water jackets leak air, you'll start seeing that you're pulling air from different spots, okay? Different breather holes, okay? Different places that you would have one of these water jackets, okay? If one of these is missing, you know, just anything, okay? It will pull air right here and here, and you will have a false high flow reading. So this is why you have to leak test the bench before you do any flow test, okay? So once this is on, you can see that there's the cream's coming around here, but some of it may not be right here. The way I do it is before I do a flow test, it's a little extra effort, but I literally put tape over every single orifice, okay? Even inside, okay? The adjacent ports, I put tape over all of the spots that have entry to a water jacket, depending on a small block Chevy head, or this LS head, just the individual pockets for the push rods and the valves. And you can see even down in here, I put tape over every single orifice, so that way when I do my leak check, even if I don't have a good seal around any of these water jackets, I still don't have any leaks. So that's something I recommend doing, because if you have any delta P across the orifice plate, or if you're using a pitot tube, if you have any velocity in the pitot tube, then you're getting flow and you're not sealed up good. And you'll have to use, if you cannot get a perfect seal, then you just need to subtract that delta P. So if I have, for example, a delta P of 4.5 across the orifice, well, if I had 0.2 before I even started, then you need to subtract that 0.2 leakage from the total delta P, okay? That way you get as accurate of a reading as you can, okay? So seal up your head, get a good seal here, make sure you're centered over the bore, okay? And be realistic, okay? If I were to completely chamfer this, it would have better flow, but that's not the way it is on your head. Your head or your block is decked, okay? It's not chamfered. It has a very, very, very small chamfer from when they do the honing. There's just a little honing ring they leave at the top, but for the most part it's flat, okay? So don't make this rounded just to make your flow artificially high. It needs to be what it's going to be in the engine. Now, if you have a 4-125 bore, I do mostly small like Chevy and LS stuff, so I use just a 4-inch bore. You can make adapters and make this 6-inch pipe come all the way to the top, and then make you adapters for different bore sizes if you want to do that. I knew I was just going to be doing it for these kind of heads, so I made it specifically for that. Okay, so let me make sure that answered this question. Specifically when it comes to this, okay, obviously get it as close as you can. Now it's on the front here, okay? My intake is facing me. Intake ports are facing me when the head is on there, okay? Let me just put one on here real quick. Hold on. Let me just put it on here. Okay, so when you're looking in there, obviously it's a lot harder to do on this camera when I'm trying to hold it, but you're gonna center that up, okay? You're gonna center it up and lay it down, okay? Once you have it completely perfect where it needs to go, you'll take a clamp it on the front, clamp it on the back, and make sure that sucker is good and rigid. Turn the bench on, put it up to 28 inches of water, and make sure you have no flow across the orifice or across your pitot tube, whatever you're using to measure flow. Okay, dial indicator. You can get these setups from just about anybody. Oh, my video cut off there. This one specifically, a Pro Check. I mean, you can get anything, okay? One full revolution is 1/1000 of an inch. So once you go all the way around, 1/1000 of an inch. 150, 200 thousandths, vice versa. Okay. I do flow tests starting at 200 thousandths lift. That's normally what you see, and my opinion on that is a lot of it has to do with valve position, or piston position in the bore, related to valve position. So for example, most small block Chevy wedge head style deals, and really most any engine, by the time the piston is at top dead center and about to go on its way back down, the valve's already 100 thousandths open. Typically the valve is 100 thousandths open 10-15 degrees before top dead center. When it starts to open, it opens quickly, and you can get to 100 thousandths lift right at pure top dead center. So this specific, and it all has to do with your cam. That's why they say duration has really nothing to do with hitting the top of your piston. It has to do with how early that intake valve starts to open. Okay, so it's not duration it's not lift. Duration is what matters. It's not lift. Okay, lift at the valve is not going to hit your piston. You can have as much lift pretty much as you want. It's the duration. Okay, because when you're at full lift, that piston's already almost all the way down to the bottom of the cylinder, so you're not going to hit it. But how early you open the valve and how late you close a valve will impact your piston to valve clearance. Okay, hope I didn't confuse anybody. I said it trying to talk really fast, but so for example, when my cam, specifically in Old Red, opens about 9 degrees before top dead center, if I were to open it at 20 degrees before top dead center, I would probably hit my piston with how tight my clearances are. Okay, so keep that in mind when you're flowing it. You're not really flowing a lot of air at 100 thousandths lift, so in the engines it really doesn't matter a whole lot. So you don't start having a negative delta in the cylinder until the piston starts moving down the bore. So you're at about atmospheric pressure when you're at top dead center, so there's no flow because you're at atmospheric pressure on naturally aspirated. You're on atmospheric pressure inside the intake manifold, atmospheric pressure inside of the piston, okay, whenever you're at top dead center. So flow doesn't really matter until you start to get closer to 200 thousandths lift and the piston's on its way down the bore. So flow it however you want, really doesn't matter. Anyway, so we talked about where this is at. Now specifically where you're at on the head. Okay, that tube is coming in this way towards the intake side. Why? Quench pad. See this? This whole area over here has a lot of air and flow movement. So if I put that tube on the other side back here and I put my head on there, it would be coming in right here, and there would be a ton of airflow coming past it, and you'd have that Venturi effect. So the idea is you want to get it as close to the deck as you can, realistically, and mine is as close as I can get. I could have angled it up, but that would actually artificially affect it. So I want square, completely perpendicular to the flow, and I want it in the most dead part of the port as I can. Okay, so it's coming in right here. Okay, that's where you want it, as close to the deck as possible on this position on the cylinder head when it's on the bench. Okay, I hope that answers several of the questions I had related to position of that thing. So next, the actual bench. So I had a couple questions. How is mine set up? Okay, so ignore the trash. I'm doing some rearranging here. So up here, I have a 50 amp breaker that I added to my normal house panel. Okay, its own dedicated 50 amp breaker. Okay, and I have that coming out to this 50 amp RV plug, 4-prong plug. Okay, this is specifically for the bench. Then you go over to the bench, This is my 50 amp RV cable. Okay. All right. I have every single one of these motors on their own breaker and on their own switch. Okay. So take this off. All right. You see what we got going on here. So basically you've got your feed line coming in, okay? You got your neutral bus, okay? And you have your hot. So the hot's going to this bus here, and each one of these breakers are on that hot bus. There's a 15 amp breaker for each motor, okay? Coming off of the breaker, you're going up, and you're going to the individual switches, okay? All right, makes sense, okay? Then, coming off the other side of the switch, you have your lines, the hot lines, okay? Your hot going up to the switch, hot coming out of the switch into the motor, okay? On the hot lead of the motor. Then you take your neutral off of each motor, okay? Each one of these motors are 2-wire, and the neutral comes down to the neutral bus. If you see these green wires, these are all ground wires grounding to the neutral bus, okay? Which is right here. Those are your neutral bus, okay? There's your ground, neutrals, hot, okay? Got it. So you always want to ground these switches to the neutral bus. Why? Okay? For those electricians out there, you know why, but if you don't, it's a safety thing. Okay, so if my 3 or 4-year-old comes out here and I have a shorted motor and that motor doesn't trip the breaker, I gotta have a dead short at the switch, and it would turn this metal box hot. And it would literally, if my boy was grounded on something and touched this, he would get hit with all of that juice and it could kill him. Okay, so, and it could be a fire hazard. It's a safety thing. Okay, so you want to ground the switches to your common bus, okay, and then ground your motors to the common bus and make sure those common buses are feed through your cable back to the wall. Okay, if there's a dead, the whole reason it's set up this way, if there's a dead short on the motor, it should trip the breaker. Okay, and that's why I have 15 amp breakers here. You want to go as low as you can without tripping the breaker every time you turn the motor on. If I put 20 amp breakers in here, they probably never turn off. They probably never trip until I have a dead short. But I like to keep some, you know, they say 30% margin. These have about a 10 amp continuous duty, but they will spike pretty close to 15 amps. When you first start them. So every once in a while, I will have one trip. This one right here is tripped right now because that motor is getting hot. So it doesn't perform as well as the others. I will have to probably replace it, but for now I don't need it, so I just have that killed, okay? These are brush motors, and eventually they will need maintenance. I mean, you got to replace the brushes on them. So I will probably have to replace the brushes on this one. But again, until I lose another one or lose 2, I probably won't even mess with it. You want to keep wires clean, as good as you can in these boxes so that you can see clearly what goes to what. And then know which breakers feed each one of these switches. So starting from the right to left, this one, that one, and I have them just diagonal, okay? So that I know which switch feeds which one. So basically, actually that's backwards. This one feeds this one, and then vice versa. This switch right here is this motor, so that one's tripped, so I don't flip this switch. All right, ball valves. You do not have to do it the way I did. you can. So these are literally just went to Lowe's, and these are gas lines. Okay, these are 3/4 inch ball valves that are specifically for gas lines. Okay, so I use these because I can really fine tune my vacuum. So when you're doing the intake side, okay, when you're doing the intake side, you're going to turn motors on until you get past 28 inches. So it may be up here at 35 inches. And then you're gonna open up the bleed valves to bleed vacuum pressure until you get down to 28 inches steady. Once you're down to 28 inches steady, you're done, okay? And you just sit it there and take your flow reading and you're done, okay? So the way I have these in here is I literally just drilled a 3/4 inch hole. And I use tough as nails. Might have some over here. I might. Let's see here. Well, it's just called tough as nails. It's a caulk. You guys can find it at Lowe's. But I use tough as nails all the way around, Teflon taped, ball valves, these brackets, and Teflon taped here, and then I use tough as nails to seal it inside. It's the same stuff that's right here. Stuff is super tough. It's very hard to break open, but you need to have, this is 3/4 inch plywood with tough as nails. That you will create a very strong vacuum in here. And if you use very thin plywood, you will break it your probably very first time. Okay. So I think I explained this in the last video, but if you're testing the intake side, obviously you want the vacuum motors to be pulling this way and blowing out. Okay. Whenever I'm doing the exhaust, I literally unplug it, rotate this bad boy around, plug it back in, and blow through. And it'll be going this way, and I'll be blowing through, okay? Yeah, so I think I explained the rest of it pretty good. This is also tough as nails stuff. If you have any questions, I'll try to elaborate some more. Thanks.